Hello, everybody. My name is Francesco Zurzolo, um, founder and co-owner of Elm Natural Builders. My name, you've got Francesco Zurzolo. Elm Natural Builders is the company. We've been in operation since 2018. Before that, I did consulting engineering, civil engineer for a decade. I worked with Dillon Consulting and SNC Lavalin. Thank you very much, Laura and Sustainable Building Manitoba, for inviting me to present today. I'm excited to talk to you guys about Hempcrete. Let's see if I can switch slides here. Oh, yeah, like that. So, what is it? Why do we love it? Hempcrete is a wonderful, sustainable, durable, low carbon, and highly efficient Manitoba grown solution for achieving net zero buildings here in the province and across Canada. Can you guys see my mouse or not really?
I have not noticed a mouse yet.
Okay, so I won't try to point to things. That's all good. Oh, I do have a pointer. Great. Okay, so hempcrete, what is it? It's insulation, it's a composite material, and it's solid cast. So what do those things mean? Hempcrete as insulation. Um, it's non-structural. It sounds like concrete, but it's not concrete. It's a common misconception, obviously, because of the name. It won't hold up your roof or your floors. We cast it or block it around standard stud frames, which you can see in the photo here. Um, it becomes solid fill, rigid, super durable. It has a host of benefits compared with conventional light frame construction that we typically utilize in North America, and we'll get into those in a minute. But basically, as insulation, we have an R2 to 4 rating per inch, depending on how it's done. The way we operate in Manitoba is we're always trying to achieve the maximum insulation value. So we are typically getting R4 plus per inch from our hempcrete just because of the way we pack it. We've had that tested at the U of M in 2020, and they confirmed that, yeah, we're getting R4 at least. We cast it or block it. We might get into spraying it or precasting, but typically our wall thickness is about a foot, 10 inches to a foot, continuous past the studs. And that gives us a super insulated wall, high thermal mass, super durable, all these kind of great things. So let's get into that a little further as we go. Here you can see the exterior of that previous stud framed wall, and you notice there are no studs except obviously at the openings where we've double studded the rough openings. But you can see this is continuous cast hempcrete. It's 6.5 inches outboard of the frame. It's self-supporting. It doesn't need to be on the foundation. We've used angle iron in the past just to give us a floor. We've also built a similar structure out of wood. It all works. It's very lightweight. So no stud interruptions for 6.5 inches around the entire perimeter of this house, um, and all the other houses that we've built. So let's keep going here. What is hempcrete? It's a composite material. And I think that's where the name originally comes from. Concrete is a composite material. It has a binder. It has aggregate. Hempcrete is the same. The binder is hydrated lime. Hydrated lime has been used for millennia as such for mortars, plasters, and pavements from ancient Hindu temples, Roman aqueducts, Japanese storehouses, etc. It's made from fired limestone, where during the firing, carbon dioxide in the limestone, calcium carbonate, is forced out, and you're left with calcium oxide, which is a highly reactive quicklime product. You'd mix that powder with water, it reactivates it, and then whatever you end up doing with it, mixing it with hemp in our case, or sand for plasters, all this kind of stuff, the lime reabsorbs the driven off carbon and reverts the limestone. That's the beauty of the product, and that's how it acts as a binder in our case. So we're taking limestone, breaking it up, turning it into lime, filling that limestone with hemp and then letting it turn back into stone on our walls. That's the long and short of hempcrete production. Um, so because of the reabsorption of carbon dioxide and because of the lower fire temperature of lime compared with cement, lime has a lower carbon cost or lower carbon footprint than cement, making a greener choice for binder material. And on top of that, the large pore structure in cured lime compared with cement provides a major functional benefit because the lime actually dries effectively and actively preserves wood or other organic material like hemp that's in contact with it, as opposed to cement, which any builders might be familiar with the fact that cement basically actively rots wood that's in contact with it. So that's why we use lime. So lime binder and the um, aggregate is hemp, not the full stock. So we use the hemp herd. You can see on the bag there, you can see the word horse. It's typically sold as horse bedding. It's the leftovers of the amazing um, hemp plant. So it's the chipped up inner core of the stalk. It looks and feels a lot like small wooden straws. Um, so hemp is a fantastic plant. It grows on marginal soils. It requires no crop inputs or pesticides. It can produce multiple crops each year and grows like a weed, basically. In terms of biomass production, an acre of hemp produces about 4 times as much biomass in a growing season as a forest does in 25 years. Hemp has been cultivated heavily in the past because of the long, strong fibers that grow along the outside of its stalk. That's typically, well, that and seed production is why it's grown in Manitoba. Um, I'm sure you've seen hemp seeds sold as superfoods at the grocery store. So the seeds, it's grown for the seeds, it's grown for the long fibers on the outside of the stalk. But what we like it for with hempcrete is the leftover inner portion. This inner portion has otherwise low value besides hempcrete or maybe horse bedding. But it's very porous on both a macro and a micro scale. It contains high amounts of silica, which bonds well with the lime, and it's very durable and naturally resistant to degradation. So that's the aggregate in our hempcrete mix. Um, I spoke a little bit about about biomass, and what I want to just put in here as our last point is that um, as we lock it into the walls, that represents physical carbon sequestration into our buildings. And we'll touch on that a little bit more later. And then the last material is water. You've heard of it. It's good stuff. So we mix it all with water. And you can see here our beautiful mortar mixer from an old stucco guy that was retiring. This thing's a 12S. It's a beast. We mix lime, hemp, and water in there, and it comes out into a sort of a dry tuna salad consistency that we like to use. So if we're doing cast in place, we'll mix this on site. And if we're making blocks, we'll mix off site, pre-cure the blocks, and then bring them to site. So hempcrete is insulation. It's a composite material and it is solid cast. What do we mean by that? It's a continuous insulation. There's no voids. It's highly impact resistant. Take a look at this baby here. You know, it's the whole house is a block. So how do we use it? When we cast in place, which that previous slide was showing a cast in place project, the material is gently tamped into lightweight forms. We typically use 1/2-inch OSB or plywood with no strong backs or stiffeners required, just very lightweight stuff strapped to the studs or spaced off depending on the thickness that we're going for. But it's a very lightweight material, and once tamped and let set for a few minutes, we can actually slide the formwork up. So this picture that you're looking at here on the screen, you can see the formwork just at the top of the screen. We've slip formed this up, you know, maybe an hour after casting this because we pass around the perimeter of the space. So Hempcrete is actually very sculptural, and with slight adjustments to the mix, adding some clay, maybe some cellulose, we can hand form shapes of all kind, which we'll show you later. But it makes a very interesting material to work with that you can slip form, that you can sculpt it. You can get some very unique forms. So we can cast in place, or we can produce blocks, as you can see in this picture, with some routing, some post-install routing for our services. Um, Making blocks has the advantage of disconnecting the build season from the drying season. So hempcrete, as a wet mix product, does have a drying time. Um, Blocks are generally more labor. Um, because you're double handling the material, but they're really handy to be able to just sort of ship out to the next project and people can mortar up. Um, Blocks represent a move towards a more conventional use of hempcrete in the context of sort of the rest of the world, where they're used to building with autoclave aerated concrete blocks or standard cinder blocks or things like that. Then hempcrete becomes sort of a no-brainer, hempcrete blocks. Whereas in North America, because we're sort of still we utilize the light frame construction, we find cast in place sort of lends itself better to a wood frame construction. The other way of doing hempcrete, or applying hempcrete as a solid cast material, is spraying it. So I don't have this machine, but there's a great guy in the States that sells them. They're made in France, and it's basically a big bazooka, blasts hempcrete onto surfaces. There's a bit of prep. I don't know if you can make out the mesh there that's held off the stone wall a little bit, but so there's a bit of prep involved in making this work, but it's got the one of the best potentials for a retrofit, for hempcrete retrofit. We're actually looking into purchasing one of these this year to meet the demand for retrofit installation on particularly older homes that have been built without a vapor barrier. We're going to get into this more in depth right away, but hempcrete is a vapor open product. So when you apply foam to the exterior of an old house that doesn't have a vapor barrier, you're basically putting a vapor barrier up on the exterior of your wall, guaranteed to be trapping moisture at the outside of your wall, and you're risking condensation and mold issues. So hempcrete allows that vapor to continue its path, as it has done in my house. I'm in a Wolseley house. Vapor is being breathed out every winter for 115 years, and we're not in the business of stopping that now. So that's where hempcrete comes in as a great retrofit insulation option. And spraying it on would be an excellent way to do that. So that's hempcrete as a material. Now, a little bit of history, not a long history in Manitoba. Uh, Dr. Chris Dick did a bit of research on hempcrete in the early 2000s and 2010s. That was when I didn't do any of that research, but I was around at the time, very interested in it, saw it, thought it was cool. But from there, it basically was us. 2018, we started. The house you're looking at in the picture here was our first hempcrete project, built 2019, 2020. This is two-story hempcrete addition built on the Fibonacci spiral sequence, and you can see some non-standard window installs. It was a fun one. We built this in the Red River Planning District. So this was the first permitted hempcrete structure in Manitoba, to my knowledge. If someone on the chat can correct me, but from what I understand, that's the first permitted residential structure in Manitoba. We worked with the Red River Planning District for that. And since then, we've been continuing to build around Manitoba. All permanent structures, Toulon, Winnipeg, and now our latest one in Beausejour. So we're making our rounds around southern Manitoba. This is the interior of that same space, or the upstairs. So hempcrete's a great fit for the Manitoba well environment and location. We grow hemp in Manitoba, grow a lot of hemp in Manitoba. I think Manitoba is actually the leading supplier for edible hemp products. And We have obviously also fiber processing facilities here at Gilbert Plains, which produces hemp herds for most of Western Canada and actually some of Northwestern US as well. Uh, Hempcrete's well suited to our harsh climate because of the high levels of insulation, its high durability, and the vapor open nature. And when I say vapor open, I do mean airtight, but vapor open. So uh, it leads to a very comfortable, um, durable interior space. Last bit about Hempcrete in Manitoba is code approval. So as I sort of alluded to, all of our projects are code approved. That said, we don't have Hempcrete written into the building code. So how do we do this? Um, uh, Actually, the Red River Planning District was very helpful in sort of working with us to get that first uh, alternative solution developed for hempcrete. And specifically, we had to produce exceptions to the vapor barrier line, the air barrier line, because we do have an air barrier, but it's the plaster layers. It's not a plastic sheeting membrane, and the insulation type. Obviously, hempcrete wasn't on the list. So using basically global research and use cases, we were able to produce an engineering document that satisfied the requisite code approvers in the Red River Planning District, and since then, South Interlake Planning District has approved it, as well as Broken Hand Planning District and City of Winnipeg. So it's a real thing. It's code approved. We'd love to see it in the Canadian Building Code. It was recently, I think last year, put into the appendix of the American Model Building Code, or IBC, International Building Code. So we're hoping that trickles up to Canada soon. But for now, we are moving each project forward with sort of one-off approval. And we have honestly not met too many barriers. People obviously ask the right questions, but we have the right answers, and we have use cases now that span a number of years in Manitoba. So it's just getting easier as we move forward. This is part of why we're here, right? Sustainability. So when we look at hempcrete and sustainability, we're looking specifically at the building and construction sector. I alluded to Laura that I was having fun with the animation. So here it goes. There it is. Boom. We're looking at the building construction global carbon emissions. And they're not small. 39% of global carbon emissions is from the building and construction sector. Now we have to understand what this means. Operational carbon is something that I think has been in the language for a long time. Like, how much energy does it take to heat this house? How much energy does it take to cool it? How much energy does it take to put the lights on and run all the things, right? That's operational carbon through energy use. Pretty well understood. Here in Manitoba, we have reasonably clean hydro. Our gas heat, we do have our carbon cost there. But there's another aspect to the global carbon emissions in the building and construction sector that is sort of, I mean, for some people it's been in view for a long time, but for others it's coming into view as we're getting better at reducing our operational carbon. We're starting to realize that there's an embodied carbon aspect that needs to be addressed. So embodied carbon are the carbon emissions produced from the entire life cycle of a material, from its design and production through deployment and finally disposal. So you get things like concrete, plastic, conventional foam and fiberglass insulations where, let's take foam insulation as an example. It's saving operational carbon. It's saving energy because you're insulating your walls, but there's a super high carbon cost to produce that foam. And then how do you dispose of it? These are major questions that honestly at this point don't have very good answers for a lot of the materials that we use in homes. So a shift in focus is required. Um, we need to look at both things. We need to look at operational carbon, and we need to look at the embodied carbon in the materials that we use. Um, The United Nations Environmental Program identified 3 urgent pathways to decarbonize building materials and processes, and so they're onto it. They say materials and processes. So the first is avoid unnecessary extraction and production. That's seems obvious. Um, Shift to regenerative materials. That's where things like hempcrete come in, where we're replacing super high carbon cost materials like foams, like plastics, with true bio-based materials. It's just such a critical thing that we need to think about as builders and as designers. Um, and then the third is improved decarbonization of conventional materials. That's great, and there's technology that can be applied to reduce the carbon cost of conventional materials. But there's certain things that just there's if it's petroleum based product, you're not gonna change it. So I want to show you an example of so this is an addition we did in Wolsey. Small addition, 2 stories, fits the house. So you can see on the exterior here, it's a lime plaster directly applied to hempcrete uh, insulation. There's no plastic except those windows because they didn't spring for low end windows, unfortunately, but that's okay. Uh, Otherwise, we're plastic free in this image. The only thing I would add when we go to the inside, which I'll show you here, is we do have vapor barrier in the ceiling um, and floor because we didn't hempcrete those. Those are rock wool insulated just because of space requirements. But when you look at this space, the floor is an earthen floor. It's clay, sand, and linseed oil, natural linseed oil, actually from Saskatchewan. The walls, again, are lime plaster, lime sand, flax fiber from southern Manitoba. The walls are hempcrete, hemp grown in western Manitoba. Um, and again, our windows are plastic. But besides the furniture, there's no plastic around. Oh, the floor has PEX tubes in it. I gotta admit, there's in-floor heat, which is so beautiful, very efficient. But that is PEX tube. So there's a bit of plastic there. But you can see, compared to a conventional house where your luxury vinyl is all plastic, your paint on your walls is all plastic. Your all your vapor barrier, air barrier, all that kind of stuff. So we've gotten rid of a massive amount of these high carbon, high cost materials uh, in this standard space. Or windowsills are solid fur. You know, um, that's the kind of work that needs to be done on larger and larger scales. But we're doing it here, and it's very doable. So hempcrete, okay, yeah, hempcrete is part of the solution. It's obviously bio-based, regenerative material. Uh, as I mentioned before about the hemp plant, it's easy to grow. Um, Hempcrete, when it at the end of life, it can be broken up and tilled back into soil and will compost there. The lime, obviously, is just limestone calcium carbonate, great for the soil, and the hempcrete does compost in the end. So we have a non landfill uh, solution and a soil rebuilding solution for getting rid of our insulation. Compare that with foam. Compare that with fiberglass. Right? We're sequestering carbon in our walls. As mentioned, the biomass from the hempcrete is entrapped in the walls. The carbon dioxide that was driven off during the lime firing is reabsorbed by the lime as it cures. There is still obviously the cost of the firing that's there, so it's not completely carbon neutral. But that said, uh, hemp is twice as effective as trees at absorbing and locking up carbon within the same area of forest versus hemp field. So while 1 hectare of forest is estimated to capture 2 to 6 tons of CO2 per year, uh, hemp is estimated to sequester between 8 and 15 tons per year. Um, Works the same way as a forest. They're photosynthesizing and absorbing CO2 and locking it up into their cell walls, and that's what we use as in our walls. Um, so with the carbon sequestration of the hempcrete and the local nature of the material, We have yet to fully crunch the numbers, but we do believe that our hempcrete walls are actually carbon negative, because even the cost of firing and transporting the lime is made up in the carbon sequestration of the hemp. I want Zane from Red North to help me figure that out. So he's gotta tune in after. Uh, and obviously it's a low carbon process in manufacturing. I don't have any pictures from the plant in Gilbert Plains, but it's a reasonably like conceivable process to go from a bale of hemp to these beautiful chipped herds. It's not a crazy. It's a small equipment, small process. Works great. Finally, I wanted to touch on hempcrete durability and health. Just checking it. Good. Hempcrete durability and health. So these things don't always seem to be directly related, um, but with hempcrete they are. Um, I'm sure you've heard of sick house syndrome or sick building syndrome. Symptoms include headaches, fatigue, irritation of the eyes, skin, uh, oops, sorry, mucous membranes. Didn't want to do that. Are we back? Right? Yeah, back to durability and health. Good. Um, I was gonna say a joke. Nah, it's totally ruined. So I was gonna say it sounded like a regular day at the office, but now I've completely ruined that. So too bad. But anyways, there is this sick building syndrome, um, and it's linked to poor air quality, mold spores, VOCs, and particulates. Even psychological factors, so stress and anxiety related to the building environment, contribute to these sick house or sick buildings syndrome symptoms. So how does that relate to hempcrete durability? Well, I've been alluding to this whole time about hemp crete walls being vapor open, and so what that means is we have the ability in a 12-inch hempcrete wall to pass internal moisture through the wall without condensation and without air movement. So it's vapor transmission through the wall. Nowadays, who do we have? The German companies that make all the very fanciest building wraps. They're onto this, and they make these smart vapor barriers and smart air barriers that are vapor open. Um, sorry, the vapor barriers aren't vapor open one way, but they are the other way to allow internal drying. So what we have is people at the cutting edge of the building science recognizing that we want our walls to be able to uh, dry, to be able to pass moisture through. If you think of um, a typical Manitoba structure built with drywall, plastic sheeting as vapor barrier, polyolefin air barriers, uh, fiberglass bad insulation. You have very moldable products that make up the entire wall. The wood framing, if water is trapped against it, will rot and mold. The chipboard sheathing, OSB, you've seen all the horror stories of OSB molding. Um, Paper face drywall, like the drywall turns black right away. In our hempcrete walls, we have none of these things. There's no sheeting, there's no plastic, there's no paper. So it's naturally mold resistant because of the high pH of the lime. So we're actually actively protecting the wood. But so what we have is we have a wall that actively dries. So we're not trapping moisture in the wall. We're not facilitating any sort of mold growth. VOCs, we basically just don't have them. We have not no plywood. We still have plywood in the floor sheeting. Um, but like fractional amounts of plywood compared to conventional builds. We don't have our plastics. We're not putting vinyl trim or vinyl floors in. Um, our countertops are earthen. In the picture here, you can just get a glimpse of that's an earthen countertop, solid wood trims. So what we're doing is we're just removing as much as we can anything that will emit VOCs over the lifetime of the building. And you compare that to your office. You've got your carpet tiles that off gassing VOCs until they start dissolving into microplastics and you eat them. You got your ceiling tiles that are just particulating down, and you're breathing that in every day. So what I'm wanting to challenge here is that we can do things better, and we need to consider human health in the equation. I got a little bit away from my slide, which is durability and health. But I think the main point there is that the vapor open nature of the wall allows for drying in both directions, which prevents rot in all seasons. And we also have almost completely eliminated VOC producing materials in all of our builds. So that's it. I had the opportunity this morning to explain to you about hempcrete, how it works, its history in Manitoba, and its environmental potential. Um, the use and incorporation of hempcrete insulation in buildings in Manitoba is one key way that we can reduce carbon emissions. So we're looking for architects, designers, and other builders to get on board with this um, as we plan sustainable building projects in Manitoba and throughout Canada. So it's a local, renewable, Canadian-made material that we just want to get used more and more as much as we can. Um, as Laura mentioned at the beginning of the presentation, there's so many things that I feel like I want to say, but don't quite know how to fit it in. So I'd love to spend the next 20 minutes answering questions that you guys might have. But I'll say again, thank you so much to Laura and Sustainability Manitoba for letting me present this stuff to you guys.
Oh, well, thank you so much for sharing all of your experience and knowledge. This is really wonderful. And so far, there's a lot of questions coming out of the chat. So, folks, keep adding them in if you want. You can put up your hand and unmute yourself if you'd like to ask your question yourself. So, I'll be watching for both the chat and for hands going up. So, to start off, can you discuss how it can outperform all the other fibers in terms of thermal performance?
All the other fibers in terms of thermal performance. Not totally sure what the specifics of that question is, but what I can say is um, the hempcrete R value, which ranges generally discussed from R2 to R4, varies also globally. So in UK and France, where this is used a lot more, they're only claiming R ratings around R2 or equivalent to their U values. That's because they produce a much denser mix. It's got a higher proportion of binder in it, and it's compacted high to a higher amount, so that you can actually have sort of uncovered free hempcrete walls. There's been houses with just like exposed hempcrete. So with us, if we were to do that, you would notice the voids there. There's a lot more air trapped in our walls because we don't pack to the same degree, because we're trying to achieve a higher R value. So hopefully that answers your question.
Yeah, we'll hear for more, I'm sure. If it doesn't, again, people can raise their hands as well. So the next question is, can you expand on its airtightness? I imagine there's a minimum thickness where that's the case. And I'm not sure if this question is connected or a separate one, but like, would it be more air untonating? Sorry.
I'll answer the first bit because I don't know what you said there. Air tightness, hempcrete. Maybe I misrepresented a little bit. Hempcrete by itself is very not airtight. You can have a 12-inch wall and whisper to somebody on the other side and practically hear them. So what we have in the hempcrete matrix, we have the micro pores. So the pores within the lime material itself, and within the actual hemp fibers, or they're chunks. They're not really fibers, but then we have macropores, and those are the things like trapped in the middle of the straw-shaped piece of hemp, and also between the chunks of hemp that don't get packed super tightly together. Well, those macropores are like open celled. You can imagine it as an open celled biofoam. So wind can blow through the wall. What makes it airtight is the plaster layers. So, and we highly detail those around penetrations. because that's obviously where the leaks will happen. But in the field of the wall, you can plaster it, and the bond is so strong, and just sort of material to material, chemically and physically bonds so well that that acts as a super functional air barrier. So we're getting low, like our blower door tests. The one house we did, um, with like no no fanciness. Like we didn't. I think we even forgot to tape over the range hood, but maybe we did tape it. But anyways, we got all air changes well below 3. I think it was 2.1 or something. So not passive house by all means, not passive house, but tighter than your what's considered a tight new home for Canadian standards. And that was without any real effort to achieve tightness. That was just the plaster by itself. We didn't even caulk. We hadn't even caulked at the window to plaster uh, uh, interface yet. So there that was just sort of like just almost dry fit. That's the airtightness with the plaster. So um, hempcrete is not airtight. Hempcrete and plaster is airtight. Yeah.
Okay, thank you. I'm just going to read some comments here before we get to the next question because I think that there's some interesting discussion going on in the chat, and if you're just listening, you might miss it. So, naturally biased here as a rep from AMC Foam, but it's important to consider that not all foam is created equal, and there are widely different embodied carbon numbers amongst different types of foam insulation. And so the response is yes, that's the main issue, is that the embodied carbon is now the real issue. Operational carbon is easy to address. So plastics, fossil fuel, and products become an issue. So just wanted to share that. Do you have any comments on that little conversation there?
Well, I'm not here to vilify anybody. I think some of the stuff AMC foam is doing is really great. Like I mean, I think putting foam underground is not a bad idea. That never gets moved or doesn't get moved for a long time. I think putting foam above ground, yeah, maybe you're getting into trouble because now you do have to calculate like how long is it likely before someone's going to blow out this wall to expand this house and all that goes to the landfill. How long is it going to be till they redo this whole side and redo the siding and wreck all the foam and that all goes to the landfill? We need to make those calculations. I do know that some foam, yeah, like polystyrene is better than polyisocyanurate and all that stuff in terms of carbon footprint. And I just think that the conversation needs to be real. It needs to really consider the full life cycle impact of the materials. So if you can never get rid of it, it's probably not a good idea to make. If you can, awesome. Uh, that's all I'll say.
Very fair. I think there's some other total cost of building ownership champions on the call here. So that's great. So question next is how much does this material weigh? For understanding, can you suggest a material that would be similar in weight or density?
Density is 150 kilograms per cubic meter. So I don't know. I don't even have a pounds per cubic foot number. I think it's 7. Someone can do that calculation and throw it in the chat. Uh, yeah, low density hempcrete is surprisingly light. Uh, I think it floats. Well, it doesn't float because it's open celled, so it just sinks. But I think if you encapsulated it, it would float. Um, maybe not.
Interesting. Feels like a summer experiment next time you go to the lake. Okay, so you've kind of touched on this, but like maybe you just want to be a little bit more explicit. So, like, what's the typical airtightness you achieve in a hempcrete build?
Yeah, so we don't have a ton of data. We're going to have more data after this current build, and we're trying a little bit harder on this one as well. Uh, so like I said, the last one we got a 2.1 or something, which I mean it's not terrible, but I wouldn't like. I shouldn't be bragging about it. I shouldn't have even told you. I mean, it's okay, but it's not great. I want to do better. I'd love to be able to sort of achieve one. Um, there. I mean, there's a bit of a comment there too. We still got a bit of time. There's a bit of a comment there too, because the there's diminishing returns. Like at so this house, this too long house that I'm talking about that has 2 air changes per hour at 50 pascals above pressure, whatever that rating is. That like if you don't run the HRV, it smells musty. It just does. And that's with all of our great vapor transmission, but you're not getting the fresh air. So the tighter you get, the more you have to mechanically ventilate. And I think there is a sweet spot. Like you don't want to be like my Wolseley home. Like it's got like I don't even want to imagine how many air changes per hour. You can smell the car exhaust if someone's idling in front of the house too long. So that's we're not by the sweet spot in this place. But um, once you get like 2, 1, I would say now you're highly reliant on all these mechanical systems to do the ventilation for you, or you open your windows, which is a very good idea. So I think the passive house standard is great. I think it's been a challenge that has led to a lot of awesome technological improvements. But I think like sacrificing everything for the sake of zero point 0.6 or zero point 0.2 ACH is maybe there's some diminishing returns there anyways at some point. But yeah, we do want to get tighter than 2. Let's try for 1. That's my goal.
Sounds good. So, would a rain screen and weather barrier be recommended if lime plaster isn't the exterior finish?
Yeah. So, um, the house we're doing right now will have a combination of plaster and wood. So definitely rain screen. And then behind the rain screen, we do still want an air barrier. So if plaster is not an air barrier, what's it going to be? So in this case, we'll be looking at polyolefin films like Tyvek or something fancier. Or, and this is a bit more labor, but the clients are truly considering it because they're trying to reduce plastic use in their house, is to do a scratch coat of plaster. Just throw it on, doesn't have to be pretty. Then put your strapping, then put your wood. Um, Definitely not the cheapest option. An air barrier, like a traditional air barrier, would be cheaper, but it's a plastic-free option, so something to consider.
Absolutely. Always want to consider the options. Also the mechanical air handling systems. So, to what extent are these systems reduced?
So for fresh air, obviously it's the same. For heating, they can be smaller. I mean, our walls are R36 minimum, basically, up to R40. Uh, we still use blown-in cellulose in standard attics because it's just hard to beat that, especially with all the drying potential up there. So we can get easily R60 to R100 in the roofs, and then foundations. This is where AMC foam, I mean, is the best. Like ICF concrete foundation is well insulated, and you get a high degree of insulation there. So all that combined makes for a much lower energy loss house. So you can physically reduce your heating, your mechanical equipment sizes. Yeah.
Great. Okay. So, everybody always wants to know about the money. So, what is the cost per square foot of hempcrete for a building, like of a hempcrete build?
Well, I'm not going to give you a cost per square foot of a hempcrete building because that's the same as any custom home. Our costs are very competitive overall, like home to home per square foot. What I can say is cast in place hempcrete for a 12-inch wall. Materials and labor, we're in there, and profit. We're in there at around $30 a square foot for a 12-inch wall. So that's installed. Um, yeah, in terms of like overall homes, I mean, custom homes are custom homes. So that's what are we building at 350 to 450 a square foot right now, depending on what you pick for your bathroom fixtures, not what you pick for your hempcrete. So there's a lot there. We This is a different subject and a different question, but there are people doing really cool work with prefabbed walls, prefab hempcrete walls, so panelized construction. Very, very cool stuff. A great way to reduce cost of these kind of things. So that's something that I haven't done any work towards, but would be very interested in the future. Yep.
Oh, that's great. Love hearing the shout outs to the prefabricated walls. That's such an interesting technology that people are developing. So, Where does the electrical and plumbing go within the wall?
Oh, you missed my third slide or something. But we typically just do hempcrete on exterior walls. Some diehards in other parts of the world have done it in every wall. Um, but we just do it on the exterior wall where we need the insulation. So most services in most houses, no matter how they're built, are run on interior walls. But for the exterior walls where it's needed, uh, an electric chainsaw and some good aim, and you can route those walls very effectively, very simply. Uh, we don't necessarily recommend plumbing on exterior walls, similar to all standard construction practices, but electrical is no problem to route after the fact. Nope, you're muted.
I was doing so well with not talking while I was muted.
Good deal.
Ine- Inevitable. Who's got that on their Zoom bingo? Okay, so somebody was going to ask about cost and assuming radiant heat or heat pump slash AC would be the best systems. Question mark.
Um, I love radiant heat. I don't know how the cost compares. Like, so I guess maybe the question is about energy cost. I think that my hunch is, and there are other people that are better at this than me, but my hunch is that um, utilizing the thermal mass in our clay floors, for example, as a heat sink and a heat source is awesome. Uh, the houses that we've built with radiant heat in the floors are incredibly comfortable and super efficient. So so yeah, if you're asking my opinion, I think a heat pump uh connected to like a air to water heat. Lindsay, you should just repeat it for me because we've talked about this a few times. But air to water heat pump, heating water that heats your house through hydronic in-floor heat is the best. If there's anybody that does HVAC design and knows of people that like to install those things, please reach out to me because I'm having trouble. I just can't find HVAC guys that really want to do that.
All right. Put your thinking caps on. Who do you know, folks? Who do you know? Okay, somebody has a question about ceilings. How do you do them?
I'm gonna roll windows. Sorry. Ceilings, how do we do them? Like in terms of hempcrete, we haven't ever insulated ceiling with hempcrete. They do that in the UK. It's really cool. You see the walls just go right up into the ceiling insulation. It's amazing. It's very monolithic and awesome. But like I mentioned before, it's tough to beat the efficiency of blown-in cellulose. Um, so most clients opt for that. So then we do have sort of a ceiling finish, vapor barrier, plastic. Yes, you heard me. So we do have some plastic. Then our framing, and then all of our blown-in insulation on there, and then lots of ventilation through the attic to keep that cellulose nice and dry.
Nice. Do you have anything else you want to say about air tightness testing? You said you've done some. Do you want to expand on it at all? Want to do?
I want to do more. That's all.
Fair enough.
Next help.
Okay. Yeah, absolutely. Okay, so how does hempcrete compare to typical residential wall systems in terms of construction costs? So, still want to know more about that construction. I think you covered it.
Yeah.
Is there anything else to say?
Like, I mean, I don't know. To be honest, I'm not good at those numbers because our wall systems don't look like, I don't know if you saw the PowerPoint presentation, or you're just listening to my voice, but all of our builds are non-conventional. They don't look, you don't have, it's just not standard. So the effort that we put into the plastering and the textures and the shapes and the sculpted shelves and the Tadillac bathrooms. I didn't show you any of that stuff, but we have a natural plaster that replaces acrylic in bathrooms. Um, you know, that's all effort and skill and craft that costs money and becomes expensive. But at the end of the day, our total home square footage cost is right on par with conventional builders that build with all conventional materials. So Anecdotally, I would say maybe it's cheaper, but it's not. It's just that we, my clients choose to spend their money in different places than other clients do. Um, Not a good answer, but that's it.
That's a great answer. That's a great answer. All right, so I'm just adding Benjamin to ask his question. He's got his hand up.
Yeah, hi, thank you. Um, I you mentioned earlier, um, whatever, you're a custom home builder. Um, I'm curious what are the barriers slash opportunities for how hempcrete could be mainstreamed in terms of whether that's spec home builders or more sort of production home building. You talked about panelization. You mentioned the code, the lack of a prescriptive code in Canada. Could you expand on the other considerations that are and the potential avenues for how that can be mainstreamed?
Well, um, good question. Very good question, Benjamin. Nice to see you. Uh, eh, my initial thoughts about this question, which are probably not the right thoughts, but when I think of other places where they're doing it more conventional, so I look at Western Europe, France, Belgium, Netherlands, England, Germany. They do a lot of hempcrete. Um, Primarily now, the format that they utilize out there is these really cool sort of full wall width prefabricated blocks that have um, channels cut in to receive uh, rebar and concrete. So they are ICF, but differently, because here our ICF is a full concrete wall, whereas there it's post and beam concrete. And then the if you're familiar with cinder block, the way they build cinder blocks, you throw the whole wall up, then you blast out the areas for your posts, and then you form it and you pour your posts in there. It's same with the beams. So that's what they do, but with hempcrete, preformed hempcrete blocks that have all the holes in there, all that kind of stuff. So that's an example of how they have taken hempcrete and mainstreamed it, and it's highly effective, especially for that type of building. So we don't build with that language here. So I think in North America, if we're not going to go that direction, which I think we just don't still, um, it would be panelized construction, panelized or blocks as an outboard insulation material. Now that's still non-conventional, um, but more conceptually approachable
Mhm,
to sort of a standard builder. Um, Anything else? The spray is really cool, really, really cool. Uh, but you have all that wet experience that I think scares conventional builders generally. So that's where the prefab or the blocks would make more sense. Kinda? Yeah.
yeah, I mean, there's a whole probably hours of discussion to be had on that.
Yeah. Yeah. No, absolutely. And then the other thing I would say, in the States, it has gotten ASTM testing and been approved for fire resistance, but hempcrete is completely non-flammable, and it achieved like zero flame spread, zero smoke production rating in the state. So that's the same as rock wool. So now these can be used as firewalls. Hempcrete can be used, hempcrete blocks or cast in place can be used as firewalls. So that's another aspect of hempcrete that like could sort of, maybe as a niche product, like be blended into code if we get that testing uh, done.
Because as it stands, can you reference those ASTM tests that have been done in any kind of current, like, code approval process here?
I tried, and it seemed like too much of a hurdle for, like, for example, our current build. We have rock wool between the garage and the house because it was just their eyes glazed over, and it was just going to be too complicated. So it's like, okay, fine, I'm not going to fight that battle. We'll use rock wool there. Um, but yeah, that could be another thing.
Cool. Thank you.
Thanks.
Right. Next, you mentioned design detailing. Do you design buildings or work with architects slash designers to detail the building?
A bit of both. Um, I like to work with architects and designers better. It's because I'm not a very good designer. But sometimes clients come with a sort of their own designs. They have sort of a concept already, and then I help flesh it out, and we get the construction drawings going. What I do love to do is take designers' concepts or other people's concepts and and show them how we can incorporate a natural material or various natural materials into their projects. So whether that is hempcrete or earthen materials or natural plasters or all this kind of stuff. So um, we love doing that. Happy to help.
Right. So you still require a wood frame, correct?
Correct.
Amazing. So we've got a lot of like nice little conversations going on about the fact that people are like "Ooh, heating hot water and then using that to heat things. Very exciting. So an air to water or ground source heat pumps are a great choice. Both can be used for hydraulic heating systems. Example, in-floor radiant traditional radiators, hydronic trench heaters. So that's some great discussion there. But our next question is, you said that there is a low sound dampening with hempcrete. Does this mean this would be a bad idea to use on a busy street?
Uh, yeah, low sound dampening until it's plastered, and then super high sound dampening. Beautiful stuff. They use it in recording studios. In the States, of quite a few projects of people that I follow that do hempcrete have done it for recording studios. The anecdotally, the spaces we've built, uh, the addition in the Wolseley addition that we built, the second story kind of almost overlooks Portage, and you can see it, but you cannot hear it compared to the rest of the house where it's blasting through the walls. So, um, yeah, very good sound dampening effects once plastered.
Amazing. Wonderful. Okay, so we're approaching 1 o'clock. Well, we're at 1 o'clock now. So just a question is somebody's wondering who you've worked with who is already familiar with using hempcrete. So a chance to shout out some people if you'd like.
Like who we've built with? No, that's just us. But designed with uh Nickel. Nickel Designs. What is her name? She designed something for some friends of ours. They wanted a house in Seven Sisters, and it was designed with hempcrete. Um, um, what is his name? Okay, he's not coming to me right now, but Ola Haraith, interior designers and house designers. We work very closely with them. Um, oh man, we had an architect help us design uh, the Grand Beach house, the spiral one. I mean, the concept was the owner's, um, but his name escapes me right now, which is a real
Is it
bummer.
Ken?
Ken, yeah, it's Ken. Thank you. Yes, Ken McKinnon, right? Is it McKinnon? I think so.
Probably.
Yeah. Yeah. So he knows a bit about it. And then we also work a lot with Charleston Engineering, who does all of our structural designs and some drafting. They're very familiar. So they do all of our structural work when it becomes more complicated for a lowly wastewater and building science engineer such as myself. So um uh yeah, any other designers? So like, yeah, Ola Haraith, the designer there, helped with the Sherburne, the Wolseley edition. Sorry, wasn't supposed to share that location. Uh, the Toulon house was Charleston Engineering, and then myself with the client. The Beausejour house is Charleston Engineering with myself and the client. Um, and then there's another house in design right now, and that'll be with Ola Haraith. So I would say they're probably the go-tos right now um for that.
All right. We're going to ask one final question, which is, do you have trouble finding trades for the plastering, etc.?
No, it's us.
You guys.
So I have a company of now 6 people, counting me and my wife. We do all the plaster. Yeah.
Amazing. All right. Any final thoughts that you want to share just before we wrap it up?
Me?
Yeah.
Oh, okay. Feel like I've talked enough, but I would say ultimately this is one prong in a multi-pronged approach to sustainability, and I think we need to all kind of do our best to like look realistically at the problem and not try to find ways of calling the things we're already necessarily doing green, but finding ways that we can tweak the things we're doing or drastically, ideally drastically improve the things we're doing um, to achieve some of these sustainability goals. So a bit of a challenge, but a bit of encouragement. I think obviously I can't do it. Obviously it's impossible. We all got to get in on it. Um, like I said, I would love to sit down with HVAC designers and figure out the best way to leverage the efficiencies of a hempcrete structure with the best way to heat it and cool it. I'd love to sit down with some window folks and figure out like how we can make this whole window sealing and window material thing work the best. And I think that's the spirit of this whole thing. It's not I don't want to be poo-pooing things and saying one thing is better than the other. Like straw bale is so amazing. Plastering it is a nightmare. But there's so many great ways to achieve these goals that we can apply creativity to and apply our art and our excitement for some of this work too. And we'll get far. So
Mm,
thanks everybody for listening. I really appreciate it. Thank you, Laura, for having me.
yeah. Thank you so much. That was a great presentation. We've got so much thank yous in the chat. So just wanted to learned a lot. That was so excellent. It's always interesting to learn about the alternative materials because you're right. We have to figure out not just the way of doing the things we're doing differently, but how to do things differently, period. So that's you said it much better than I did though. Thank you. And thank you everybody who attended. Reminder that we have our in April, we have our 3 sessions coming up. So please take a look at those. More information to come as it's available. And have a great day. Reach out anytime. Please get involved with SBM. Again, it's just a great group of people and doing some really impressive work that we'd love to share with you. So yeah, thanks everybody. Have a great rest of your day.
Thank you.